uh, construct a line parallel to line L through point P, and then we're going to prove our construction. So the first thing you want to do is you want to use a straight edge. You pick any point to the left of P, don't make it directly beneath P, any point on L, so you can call it point A, and you draw a straight line through P. So it joins A and P. So this point over here is, let's say, point A, what you have right here. And you basically, again, you just draw that straight line through A and P. Now, after you do that, you take your compass and you measure the distance between A and P, and you draw that arc. So I'll try and draw. Oh, I can't do it with that. That's okay. So what I do is again, I take my compass and I go from the center A, so this is the center A, and I draw the arc from A to P. So this is the first arc that I draw. Okay, and this should be a perfect arc, perfect circle, or a perfect semicircle, right? Like that, with center A. Okay, my drawing is not a perfect semicircle, but with your compass, it should be a perfect semicircle. You can call this new point B over here, it doesn't matter. Well, let me do a different color, let's see. You can call this new point B right here. And basically, after it is that you do that, you keep your compass open the length of AP and AB. These two lengths are the same. And you go to point P, this point right here, and you draw another arc of that same length. So I'm going to try and do it so it matches. So I actually do have a line, so I'm going to use this. I'm going to say I'm going to measure, right, AP, and then I'm just going to move that line over so I have some accuracy here. And now I have this here. And again, what you want to do is you've already drew this green arc. Keep your compass open that same amount, but move the center to P now, and draw this arc. Draw this blue arc. And you can call this point C right here, what you have right there. And you're okay. Now let's just make C a little bit more visible and say this is point C. And then after that, what you do is you want to open up your compass to the length of PB. So you want to measure this distance from P to B, and you open up that compass to that exact length. And you go to point C and you draw the arc of length PB. So that'll look something like this, maybe. Okay. And you'll see that this blue arc and this orange arc are going to intersect at some point. So that point, you call it point D. Now my claim is that the line joining P and D is parallel to L. So I try to do it. It's not perfect, okay? But your drawing should be pretty close to being perfect, or it should be precise, okay? Now why is it? Let's prove that this line M is parallel to L. So let's go through what I did here again. So I first picked some point A and I drew this line and I drew this arc. Now this green arc, okay, this length, right, I went from A to P and I kept the compass that same length and I drew this arc from P to C. So then that means that A to P, this point P over here, right, A to P should be the same length as from P to C. Now also true, right, A to P is the same length as P to C. We just said that. They're constructed in the same way. So I drew this blue arc and this green arc. So every point from A to this green arc should be the same length from P to this blue arc. But D lies on this blue arc. So from P to D should be the same length as from A to B, as it is the case from A to P. So this length is the same. These four lengths are all the same. A to P, A to B, and P to C, and P to D. Now, I opened up my compass to the length from P to B. So this length from P to B, let's draw that, from P to B, should be the same length from C to D. Right? I opened up the compass to the length from P to B, and I drew this arc with center C. So from C to any point on this orange arc should be the same length as from P to B. So these two sides are congruent. This side PB and CD are congruent. Now, if you look at this picture, right, this triangle APB is congruent to PCD because PC is congruent to AP, and AB is congruent to PD, and PB is congruent to CD. So I have side, side, side. So these two triangles are congruent. If I call this angle angle 1 and then this angle angle 2, they must be congruent because of CPCTC. So these two triangles are congruent, right? That means that all their corresponding parts are congruent. And that means that angle 2 is congruent to angle 1. And if you look at this picture again, if I simplify it, if I say that this is M and this is L and this is the line, right, then this is going to be 2 and this will be 1. I showed that this angle is congruent to this angle. If you look at this picture, 1 and 2 are corresponding angles. And if corresponding angles are congruent, then the lines are parallel. So 1 in this, back to this diagram, 1 is congruent to 2 by CPCTC. Corresponding parts of a congruent triangle are congruent. 1 corresponds with 2, and these two triangles are congruent. Therefore, 1 is congruent to 2. And these two angles in this picture are corresponding. And if corresponding angles are congruent, then the lines are parallel. And this guarantees that the lines are parallel. Now I'm going to write out statements and reasons and say this whole thing again. So from our construction, we already have a certain set of statements. So we already have that AP, right, is congruent to PC. AB is congruent to PD. And I have PB is congruent to CD. And this is all by construction. Two. Now that means that I have 3 sides in this triangle congruent to 3 sides in this triangle, which means that the triangles are congruent. So that's my next statement. A, P, B is congruent. This triangle here is congruent to this triangle, triangle P, C, D, and that's by side, side, side. Now I know that these two triangles are congruent, therefore all their corresponding parts are congruent. So this is angle 1 is congruent because their corresponding parts is congruent to angle 2, and that's C, P, C, T, C. Corresponding parts of a congruent triangle are congruent. 4. my last step is to say that my constructed line M is parallel to L. So L is parallel to M. And the reason for that is that if you look at this picture, 1 and 2, the relationship between them in this transversal and the two parallel and these two lines, let's say, is that they're corresponding. And there's a postulate that says that if corresponding angles are congruent, then the lines are parallel. So these two angles, they're corresponding and they're congruent, therefore L is parallel to M. And I say corresponding angles, converse postulate. And this proves that my construction does what I want. I constructed a line parallel to L through point P.